Okay, so I've been doing Kotlin for a while now. I don't know. In my head, it's bigger a deal than it is, but I've been doing Kotlin before it got famous, before Google decided to adopt it. But then, of course, Google announced that it's like an official language on the Android platform. Now, everyone loves Kotlin, which makes me happy. Anyways, but you're here. So how many people have used Kotlin before? 2? We'll go with 3. Okay. How many of you are considering it? But you're curious at least. Okay. So as I was saying, I've done this particular kind of talk a number of different ways. I've done it from where I call it like Kotlin from the ground up. So we started like the basic level, and here's what a class definition looks like, and here's what, and that's interesting, but not necessarily terribly compelling. And I've done versions of it where I'll take like 2 or 3 big topics and I'll do like medium dives on them. So a little bit more detail, but not really like a full talk on it. And those are sort of fine, but sometimes some sections run long and squeeze out the other, so it's not really deep enough to get like really into the meat of it. But anyways, so this talk, what we're going to do, this is my first run of this particular talk, so hopefully it'll work out. What I want to do is I'm going to give you like a giant fire hose. We're going to try and get through all of this tonight, okay? Because all of these are kind of interesting aspects of the language. We may not get through all of it, and that's fine. At least fine for me. But if you have questions about what's going on with any of this, I'm happy to answer questions afterwards when we're done. Hopefully we'll get through all of it and we can have discussions, but we'll see. So I speak most at conferences, but often enough at user groups, and I enjoy the user group experience more because I'm a little bit of an informal presenter. I don't really do slides as such. And I like interaction, I like questions, and I like being able to answer, because the point of you guys coming to talk to hear anyone speak is you want to learn things, right? And if there's a detail that maybe it gets glossed over, or it's confusing, like, what's up? So feel free to raise your hand and ask questions as we go, and we'll try to get all of it. But this is the plan, and then we can circle back on anything we've missed. Make sense? Big thumbs up. Okay, so we're going to try and make this. Now, the first thing I want to talk about is if you've heard anything about Kotlin at all. Let me make sure that stays pinned. I'm going to close all the others. So if you've heard anything about Kotlin at all, one of the first things you've heard is that it has nullability built into the type system. Who has heard that? That there's nulls in it. So what that means for those of you who haven't, we're all Java developers, I'm going to assume. So let's say we have a name and it's a string. Now, I'm not going to go over the exact syntax of Kotlin because some of it should be fairly obvious. But so we have a variable string. Is that big enough in the back? Good. Is it too big? If it gets too big, we can shrink or scroll. Anyways, so now we have a variable called name, and it's a type of string. And what makes us, if you're a Java developer, you're like, big deal, right? We do this all the time. But if I do this in Kotlin, you'll see I get these little red squigglies because this is a string and not what I like to call a string. So the question mark says this might be null. And the compiler will actually force you to check for if it's null or not before you can use it. So if I were to do, let's get rid of that. Not that it matters a whole lot. If I were to do name.length. That's hard to read with all the big fonts. Now you see the red squiggly? That's because name might be null, and you haven't checked it yet. All right? So I converted a giant project from Java to Kotlin a few years back, and I found all sorts of places where I had a null pointer vulnerability and I didn't know because I was just lazy and didn't check. But the compiler actually forces you to check it. So one way you can do that is if name not equal to null. Stop it. That'll work. maybe. All right, ignore the red squigglies. I don't know why it's down there. But now you'll notice the red squiggly is gone because we did the null check. All right, now this is what's called a smart cast. Since it's already done the null check, name gets smart cast from a string to a string. So inside this block, we know that name is not null, okay? And this is handy in a number of ways. We'll come back to this feature maybe later in the part where we talk about contracts, where you can actually kind of define your own things. But the Kotlin compiler supports smart casting. So in Java, for example, if you have a foo, and you're like, if blah is instance of bar, right? And if you're in block, inside the if block, you still have to cast foo to bar and store it in a local variable in order to use it as a bar. But Kotlin will actually smart cast it. So inside that block, it knows that foo is a bar, and you can treat it as a bar inside the block. In this case, it's doing the same thing with nullability. So I don't want to belabor that because there's a lot to get to. But you can do interesting things with Kotlin. If you don't want to do the if check, you can do the if check and it's fine. Feels very kind of Java-ish. But there's a function, an extension function, which we'll cover soon, this is defined on any. The parent type in Kotlin is actually any instead of object. There is no object, it's any. So let is a function that basically inside this lambda, you can see there's a variable called it. It's an implicit parameter inside your block. It is of type string. String? So you can reference everything that you want in there. You can do stuff like this. Oh, not this. It.length. Now you see you still get the red squiggly because it is a string, but you can do this. This is the little Elvis operator. So it says if name is not null, then invoke the let function against that particular reference. Now you see it is a string and not a string. So a couple of scenarios for nullability checking. Now you might think this is a little trivial thing to say for talk about why Kotlin is awesome. But in all honesty, if they added this to Java, it would be mind-blowing. This is a bigger deal than it feels. Because if you're doing chained method calls, which is arguable style, some say you shouldn't do chained method calls, but we all do it because, right? But in Java, you never know. You say get foo, get bar, get blah, blah, blah. And each time you have to check if it's null, is it null, is it null? Then you have to do if not equal null, if not equal null. And you have like this little triangle of ifs, right? With Kotlin, you can say name.foo, question.bar, question.blah, question.blah. And then if at any point in that method chain, any of those is null, it just stops. In Java, you'd get a null pointer exception, and you'd have to go track down where you screwed up. But in Kotlin, you can kind of short circuit that. You could use optional, but optional actually makes it much more, there's a lot more code to write at that point. Because you have to say get or else or map or if present and kind of all that. It's doable, but you're writing a lot more code to get there as opposed to just question dot, right? It's doable, but to me this is cleaner and much, much shorter. So nullability, it's a big deal. So let's talk extension functions. Now we mentioned let earlier. Who has ever manipulated strings and wanted like title case it? You take the string and make the first character in uppercase and the rest of it lowercase. Like you're trying to like normalize someone's name, right? And we've all written that function where we take the first character, uppercase it, append the last. So if we did that, call it name casing. We're going to take a name, string, return a string. So normally what you do is you do something like you could just say name. Now, name, not in. All right, I'm going to blow your mind a little bit. This is an operator defined on string. So instead of saying I have to say .char at whatever, you can just address it like it was an array, right? You can do that with lists. You can do that with arrays, obviously. Maps have a similar syntax if that was a map key. Anyways, so you could do this. 2 uppercase plus, and what's the, well, let's do substring, and we'll start at 1. So now we can do print name case Justin. Now we'll see how big the font is on the output here. It's the one thing I never can quite figure out ahead of time. It's compiling. So here you can see, can you read that? We got the proper thing, right? And that's doable. But what if we did this? We don't want to pass in the string. We can say string.namecase. Right. What's that? Do I need a return out of this function? In this case, yes. But what's that? Well, the function in this context needs the actual. You're talking about the return keyword. The function will need the return keyword. In certain contexts, you can skip that, but not in this particular case. Like if it was a lambda block, the last line could be return, an implicit return without having to use a return word, and that's useful in some cases. But in an actual function, you need the return key. So, anyways, we can do this instead. And now we can just call namecase on string as if we own string, right? Now, again, if you've ever used anything like Scala or Groovy, extension functions aren't going to be necessarily a new concept, but they're super handy. And they reduce a lot of boilerplate. They can make your code a little bit more fluent in certain cases. You can imagine if you're trying to chain functions along, if you have to keep calling out to a static method, it just feels weird to have to call the thing and then pass it around. You can't really have a fluent interface with a string of static methods, right? Because all the return types get wonky unless you're very diligent about it. But you can define an extension function on any type that you want, whether you own it or not. Because in practice, what this boils down to is in the bytecode, namecase is still a static method that you call and pass in name, and it works. But syntactically, it looks like this, which is handy. So there are a billion extension functions inside the standard library inside Kotlin, which are nice. There's a lot of some are on some of the collections. Who here likes list literals? Whoever wanted to create a list literal in Java? New array list, blah, blah, blah. It's just annoying. It'd be nice to be able to say list equals, we'll call it this, right? It'd be nice to be able to do that in Java, right? Well, the truth is you can't quite do it in Kotlin either, for reasons, but you can do this. And now we have a list. It's a little bit shorter than new array list, a little bit nicer, and these are all defined in the standard library. And then, I don't know if I can find any interesting. There's some interesting functions you can add on. See, this is an extension function on collection called isNotEmpty, and it does, what does it do? It calls not_is_empty. So very, very complicated, but it's an extension function that the Kotlin standard library defined against the Java standard library, right? So one of the nice things about Kotlin, one thing that makes it so awesome, is there's a lot of really well thought out nuances to the language and to the library, like this. So that would. The scope of that is just to where we. You would import it. It's like importing a static method. It's not globally visible, but once you import it into your file, it's visible inside that file. That makes sense. You can also scope them if you want. In this particular case, when we defined our extension function, you'll notice I defined it inside this class extension functions. So it's actually scoped with inside this particular class. And you can get at that in certain ways outside of the class, but if you wanted to have just like a local helper function, you could squirrel it away inside of a class and not have to bother with it. While we're on the subject, because it's marginally related, who likes writing singletons in Java? 2 people. Nice, okay. Well, Kotlin borrowed something that if you've done Scala, you've seen. There's a thing called an object. And an object is a compiler-enforced singleton. It gives you an instance as part of the language. You can't instantiate it. You can subclass it, but you can't instantiate it. And they were referred to by name. But what you also get inside I think I got that backwards. Yeah, let's try this. Try that again. Companion object. Each class has a companion object by default. So where normally in Java you would do static methods on a class, you can actually define them on the companion object. So if I had a function foo that does something, then I could just say, I could call foo, or I could say extension functions dot foo. So companion object, or objects are referred to by name. So the instance is the same as this. The instance name is the same name as the type name. In this case, it's a companion object, so the name of it would just be extension functions. But if we were to do object foo, like so, then we could say things like this. And then these are essentially, this is a singleton. I can't actually, if I tried to say, if I tried to create an instance of foo, it actually gives you compiler error. It says, expression of foo cannot be invoked as a function. Right. So what that's saying is the empty brackets is an operator that's tied to the invoke keyword. So it's trying to find an invoke function on the foo type and it can't find it. So that's actually what this error is saying. So even though it looks like a constructor call in Kotlin, it's trying to call an operator. So anyways, extension functions. Now I'm building something with all this. I know it seems a little disconnected. Lambda with receiver. Who has worked with Java 8? You've written lambdas and you've passed in things, suppliers and producers and everything. They're handy, but the problem is I don't have one set up yet. So the problem with that setup is that say you have a block of code that you want to execute against the type that you're passing it into. Say it's like an apply block. So like take this block of logic and apply it to an instance, and you pass foo.apply and you pass in a lambda. You have to then pass in the instance of foo into that lambda, whatever that interface looks like. It'd have to take a parameter of the object that you want to manipulate. Kotlin fixes that for you. So you could have, I knew I'd forgotten to open one of them. Let's see if I can find it. I have a whole bunch of projects. Bottle rocket. And there should be a project there already. Now, the details of this project are not terribly important, but it will lead up to my next point, actually. Open existing project. I knew it was there. So I used to work at MongoDB, and I worked on the Java driver, and there were things that I was trying to test that were complicated. So I wanted to write a DSL to help configure it. None of this is terribly important, but sometimes the context helps. So what you're looking at here is this is a DSL to configure MongoDB, and that's about all I want to say. I'll talk about it if you want, but it's not really the point. So in this case, I just want to point out this bit right here. You guys use IntelliJ? These are helpers. These are not actually in the code. This is what IntelliJ overlays. You see it a lot more in Kotlin than you do in Java because Kotlin does type inference more, and so the IDE will help you say this is an int, that's a string, but it's not actually in the code. But it does make it a little bit hard to read on the screen. Anyways, so in this case, I want to create a configuration object, and then I want to configure certain things about it. So this is what this function looks like. So I have a function. It's a top-level function because Kotlin, you can declare functions outside of a class, which is handy. You can also declare properties outside of a class, if you're into that. So in this case, this is configuration, and it's going to take a parameter called init, and it is this little bit of syntax here. Says it's going to take a function, okay, that takes no parameters, and it returns unit instead of void. It's called init. Now, what's interesting about this here is you'll see this. Now, that looks like, remember we just looked at the extension functions, right? So you give it the type dot and then whatever. So this is a lambda, is what this thing is saying. It's saying take in a lambda, takes in nothing, returns nothing. But it has a receiver type of configuration. So what this means is everything inside that block is resolved in the context of the configuration object. Does that make sense? So inside that lambda, this is the configuration object. Have I lost everybody? I'll do one better. I'll show you an example. If we go back to this giant block of code here, now you notice I added this line because it's meaningless inside the context of the code, but it kind of illustrates my point. You see, there's the this reference, and I assign it to a local variable called x, and you notice that the type of x is what? It's configuration, right? So even though I'm passing in this lambda block to the function configuration, because the lambda has a receiver type of configuration, internally, everything is resolved against that configuration type. Does that make a little bit more sense? What's that? It reduces a little bit of the boilerplate when you're trying to build. In this case, I'm building a DSL. If I did not have this receiver type, for example, here, what in the world is going on? There's my function. So if I just took in a lambda, I would have to say I want to pass in config, and it's a configuration. And then I couldn't do, we'll ignore that because it's not really entirely the point. But if I went back to this, now you can see that all these things system log turned into, it looks brown on the screen, but I promise you it's red on mine. You see the it type now is configuration instead. So I'd have to come in and say that. Now you can see system log resolves because I have to manually say this is the context against I want to resolve these types. Does that make sense? So extension, the lambda with receiver makes this a lot cleaner and much less boilerplate. I use it to build a Mongo configuration DSL because I like abusing things. If you look at, there's a project out of JetBrains called Ktor, which is sort of like, it's like their Vertex. It's not quite Spring Boot because Spring Boot does everything. But it's like a mini web framework. And out of part of that came an expression to build, DSL to build HTML pages in typed Kotlin. So you can actually have your H1, your CSS, your title, all that. Those are actually all Java Kotlin functions, and you can have your HTML compile time checked. So if you try to use a tag that didn't exist, it would just not compile because there wasn't a function defined for that particular tag type. But then it's all a DSL, so when you have like a body tag, it takes a block, and you can add in your H1s and your A's and your L's and everything. It makes it makes your DSL much easier to read. What did I just do? So I have a whole talk on DSLs and all the magic involved in there. We can dig into it if you want, but let's move on to the next one. And we can certainly happily come back. Delegation. Now this is a fun one. Who here has ever tried to implement a list interface or written any swing code? You implement someone's interfaces and there's like 80 methods on it, but you only want the one, right? The action or whatever, but you have to implement all the others because Java says you implement the interface, so implement all these methods. Yeah, if those interfaces have those default methods, but not all of them do. So in this case, what I want to do, I want to showcase, we're going to build a list, and what we want to do is we want to build a histogram so we can show the size of the list over time, right? So all we really want to do is we want to hook into the add and remove methods to update some state, then add a function to display the histogram, right? Now, if you were in Java, let me see if I actually have, I don't have that version. That's fine. So if you're in Java, if you've ever looked at the list interface, you know there's like 20 or 30 different methods on it. Add, remove, add all, index of, blah, blah, blah. But we don't care about all those. We want add and remove, right? So Kotlin has this feature called implementation by delegation. We've all heard, favor composition over inheritance, right? So even if you compose, you still have to write all the code to delegate. Like I want to implement list, but instead I'm going to delegate to an internal list. You still have to write all that code to do the delegation, right? So you're still implementing that entire interface. So Kotlin fixes that for you. So in this case, we're going to create a listogram, and we're going to declare our internal list to delegate to, right? In this case, it's a mutable list because in Kotlin, a list is immutable. You can't add to it. So you have to explicitly say, I want a mutable list of string. And we're going to say, this is a default parameter that Kotlin also supports, which is also awesome. In this case, if you just say listogram and pass nothing, you're going to get a free mutable list. Or you can pass in one if you want. And we're going to say we extend the mutable list. There's no extends or implements keywords in Kotlin, which is nice, because now you don't have to kind of worry, is this an interface? Like, I forgot, and then it gets weird. You say colon, you give it the type, right? Now, in Java, the next step would be to implement all 30 methods, right? And then manually delegate. Or you can tell your IDE, delegate for me. Some of them will do that, some of them won't. But Kotlin does this. So you'll notice this by list. So by is a function. It has multiple overloads. In this case, we're going to delegate this extension. So we're going to extend by delegating to list. And this list is this guy that we passed in as a parameter to our constructor. So we're going to delegate to the field in this case. In Kotlin, this is simultaneously a constructor parameter and a field definition because it has val in the front. Without val, it'd just be a parameter. With val, it's a field. Sorry, property. It's Kotlin. Java fields, Kotlin property. Anyways, so it says we're going to delegate to that list. So now every time we call a method defined on the mutable list interface, what's going to happen is it's going to look inside our class file. It's going to try and find that definition. It's not going to find it because we didn't write it. So it's going to delegate to the method on the list reference. Okay? Making sense?
Question.
Yep.
So can you have multiple constructors in Kotlin?
Yes.
So if I didn't put a private val on list in a separate constructor, would my object not have a list if I use that constructor?
Digression. Constructor. You have to call another constructor in Kotlin, whether it's super or this. And let's see why it's complaining about this. Oh, right, because let's say it didn't like because we have a default argument so you can have an empty constructor call, but also I was trying to define an empty constructor and it complained. But just for the sake of argument, we'll say this one takes a size, right? So then what you could do is, in this case, I'm ignoring size because I'm not passing it along, but if I wanted to use it, I could do this. I could do mutable list, and it should take size parameter. Oh, and then it wants, it wants something to, fine. It gets very picky about its types. What it's wanting is, I want to declare the size, but also wants like an init block. Why are you complaining? Anyways, I'm not going to wrestle that one to the ground, but that's what a constructor would look like, a secondary constructor. But you can't declare properties on a secondary constructor, only on the primary. So in this case, you would have to delegate. If you wanted, you could do, you could have a body on the secondary constructor and then initialize any properties if you wanted to that weren't in the parameter list for the primary constructor. Yep. So. The what now? If you create one, it's sort of like Java. You get, well, if I don't create any constructor here, then I get a default no-arg, just like you would in Java. And then if I create one, then I don't have a no-arg constructor, although it looks like I have one because the default argument here. But the rules are virtually the same as Java, because it ultimately compiles on a bytecode. If you define an implicit constructor, the compiler won't give you one. If you don't define a constructor, the compiler will give you an implicit no-arg one, because that's just how the JVM works. Does that make sense? Okay, so at any rate, so now we've defined two methods, add and remove, and all they do is they'll delegate to the list, and then we're going to add to history whatever the size is, right? And then remove, we're going to also update the size. So now in the histogram, if everyone used Java 8 streams, yeah, okay. They're not bad. I still prefer Kotlin. I'm slightly biased, I suppose. I actually learned Kotlin streams before I learned Java 8 streams, because Java 8 streams happened when I was at MongoDB working on a Java 6 based project. So I could read blogs as, that looks nice, but I could never actually use them. So by the time I got around to using them, I'd already used Kotlin, and it kind of ruined me on Java 8's stuff. But they're lovely, whatever. So all of this is doing is it's grouping and adding and summing to build the histogram, so that when we run it over here in my test, you can't see all of it because the text is really, really large, but I'm adding a bunch of stuff, I'm removing a bunch of stuff, I'm adding in some sleeps, and then I'm adding and sleeping and this and that and removing and blah, blah, blah. So if we run it, all right, font size strikes again. All right, because all the sleeps. There, we get our histogram, and we only had to write 3 methods to do it, right? So that's delegation, and there's a number of other delegations as well that I won't necessarily go into all of them. But if you want like a non-nullable type, but you're not quite ready to implement it yet, you can do a delegation. There's lazy delegation if you're doing like an expensive computation, but you don't want to do it until you actually reference that property, because maybe you never will. So why go download, the 50 meg image to do the whatever? You can do lazy delegation if you want. It'll still be nullable or non-nullable, so you don't have to do null checks, but it won't be evaluated and initialized until you call it the first time. So there's lazy delegation. You can do delegation by nullable. There's stuff there. So how long do we have? Till 8:15, 8:30? We're good, I'm told. Party on. All right, so inline classes. Now this is the one I'm actually really quite excited about. Who knows about Project Valhalla? Okay, so what Valhalla is, it's a project that Brian Getz is working on to basically work on value types. Right now, every class in the JVM has a reference, and there's bookkeeping around that reference type, and there's memory constraints. So it'd be nice to be able to say, here's say a C struct sort of a thing, just use it. So it has no identity, it just has a value, right? And then you can do some interesting things about moving those things around in memory, they're cheaper to use, and blah, blah, blah. But we don't have those yet because turns out it's complicated to build that sort of a thing. So let's take a look and see what Kotlin gives us. So let's have a dummy function here. We're going to process someone's college tuition. All right, so we're going to take in the tuition, we're going to take the interest rate, and then we're going to calculate how much you owe after the first year. This is probably not right. This is probably not how actual financial institutions work. It's okay. Unless you want to pay me at the end of this, whatever we calculate, I'm happy to take your money. But this is not probably how your bank works. But we have two doubles, right? And how many people have ever swapped function parameters and not really noticed it because they're the same type? And you get like a weird bug, you're like, what in the world just happened? I'm passing in the right values and nothing's working, right? I've done it. So there's this thing called tiny types that fixes that. So rather than passing in a string, you'd pass in first name, right? And you could only pass in first name. But the problem is now you're passing in an object, and in JVM that can be expensive if you're doing a lot of it, especially if you're doing like, say, big data processing, where you're trying to like build models and you have all this stuff going in memory. There's a lot of it, right? So all right, I'm going to try this. Tools, Kotlin. I want to show the Kotlin bytecode. Now this is going to probably not be quite as awesome as I'd hoped because the font sizes are insane. But so just to prove my point, let's do this. I'm going to hide you a minute. We're going to flip it, and if we run it, we're going to get two separate values, right? We're going to get the right one first because now that person now owes almost $45,000 after the first year because interest is terrible. But we screwed up, and now that person only owes $5,000. That was a good year. So one way to fix it is to introduce types. So let's create, we're going to pass in tuition. $40,000, and then I believe I called it a rate. So now, of course, that doesn't compile anymore because we have to update this guy. So we're going to do this tuition, and this is no longer double. This is a rate. Now you can see we got little red squigglies because we no longer have numbers anymore. So we have to go get the price of the tuition, and then the rate. All right, perfect. Now, if we want to come down here and do this again, if we try to flip the things, now the compiler caught us, right? We did it, we're type safe. But now we're paying the cost of those objects, right? Less than ideal. So if we look at the Kotlin bytecode, I'm going to cheat for just a second. And I'm going to take us back to the double because we want to see what that looks like. Right. So now if we look at the bytecode, I'm going to see if I can't. We'll just make this really big. Now, how many of you have had a lot of experience reading bytecode? I haven't. Okay, so don't feel terrible. So this is process. You can see it takes D and D, so it takes two double types. We're doing load, 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 push, divide, multiply, add. Fairly straightforward, if slightly arcane, right? If we look at the next version of it, you can see we take in tuition, we take in our rate, and now there's not null checks that the Kotlin compiler adds in. Now we're doing A loads and invoke statics and line numbers and whatever is happening here, it's clearly much more complicated, right? So we're definitely paying a greater price for using these types. So what Kotlin does to fix that is what it calls inline classes. So here's our class definition, right? Standard Kotlin classes. But if we do this, now what this tells the compiler to do is whenever you are using these classes and dereferencing these fields, these properties on the classes, it'll actually inline those in place. So what does this mean in practice? It means it looks like this. So if we come back here, all right, so this is our first one, just for memory's sake. We're going to load, 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 push, divide, multiply, add. Pretty straightforward. Now, if you'll recall, our second method, our second function took the tuition and rate types, right? But they're classes, and it's terribly complicated. But now we did inline. And you'll notice now it looks just like the one that took the doubles, right? So now you get the type safety of having an actual type, but you get the performance of having, not primitives because they're double is still a type in Kotlin, but whatever. But you get the exact same thing as if you were using double. I will take just a slight digression here for the compiler nerds. You may be wondering, this is a class in Kotlin. You're wondering, like, isn't that slow, everything? That's why we don't use wrapper types in Java, because using integer over int is so much slower, right? Well, Kotlin's very clever. If your type is double, it can never be null, right? And a primitive can't be null, right? So what happens when you compile this down to bytecode, that double becomes a lowercase double in the bytecode. So it looks like the Java primitive in the bytecode. But if I did this, now it can be null, and primitives can't be null. So when the compiler compiles, it'll actually compile with the double wrapper from the JVM, and then it has to do all of the class stuff that it does. So that's why it looks so nice and clean in the double version versus the double. So those are inline classes, and these are very, very exciting. It's not quite Valhalla, because Valhalla will do more. One of the downsides to inline classes, at least for the moment, maybe they'll change it, maybe they're not, you can only have one field. You can have one public field on it. Less than ideal, but it's a step up, right? So where you can use them, they'll be super helpful. If you can't use them, well, you're no worse off than you were before, right? But this will give you some type safety, and then you can, if you're a fan of tiny types like I am, you can make all the tiny types you want, and your address can have first name and last name and street and zip, and not worry about strings and numbers. Inline classes, super handy. Okay, so sealed classes, these are a little bit more exotic. No matter where I look, I'm going to cough into a microphone. So sealed classes look a lot like enums, right? So we're going to have a sealed class. So what a sealed class means is the subtypes for suit in this case, because anytime you're talking about enums, the obvious problem you're trying to solve is a deck of cards, right? So suits, and of course I only did 2 of them because I'm lazy. But in this case, the sealed class, all the subclasses for suit have to be in this file. And then the compiler can do exhaustive checks, like when you're doing a when check, which is sort of like a switch in Java, only better. It can check and see, like with an enum, if you're doing like a switch on an enum and you left off a few of the enum types, the compiler will say, maybe you might think about putting like a default branch or finish out, right? Everyone's seen that error? You get the same thing with sealed types, right? The difference between a sealed type and an enum is that with an enum, you basically get one instance of each of the types in the enum, right? So if this was a suit enum with all 4 types, you'd get a diamond, heart, spade, and a club, right? And those are essentially singletons, barring any class loader magic. With a sealed class, that's not actually the case. The subtypes are sealed, so you can't necessarily create any new ones, but you're not given any instances. I can create 1,000 instances of heart if I want, which has certain handy things. And also, where this differs, and I have to confess, I don't quite understand this particular design decision, but it's possible. So if I were to do just this, for example, I could not define any other suits, right? So A square is like a special case of a diamond, right? It's just the angles are constrained. And an artichoke has a heart, right? But I can't actually subclass them because they're not open. Kotlin classes are final by default, and you have to say open to make them subclassable. So anyways, so here you can subclass diamond. I created a square suit. An artichoke sort of looks like a heart. So what does that mean in practice? If we come down and look where they're used, right, because I didn't test. So in this case, as I mentioned, here's the win, and you see I only have heart, I don't have diamond there, and it's complaining about it. So it tells me add the remaining branches, and then it gives me diamond. Now you'll notice that it didn't do square, and it didn't do artichoke, because all it knows when it comes to suit is heart and diamond. So technically you're not entirely covering all the possible suits, and that feels like a broken thing to me, but in my mind I might be conflating sealed classes and enums a little bit too tightly. But in this case you can get compiler help when you're missing a branch with a sealed case, and you can create multiple instances, which you can't with an enum. And that may or may not do it for you, but
isn't a square diamond?
this is actually that's a fair point, because if I did pass in a square, it is a diamond. So technically this will cover all the types, but you're not explicitly. I could come in here and say is square. I could do that. So you're right, the polymorphism will catch it, so you can still cover all your bases. It just feels weird not to have them listed in the branches. Side note, this is a to-do built-in thing. Everyone's seen unsupported operation exception? This is essentially that, but this function returns nothing, which is another type. If any is the parent type of all types in Kotlin, nothing is the bottom of every tree. If you imagine a diamond, nothing's at the bottom. In this case, this method returns nothing, which tells the compiler this thing will never ever return. And in fact, what to-do does is it actually throws an exception out of it. You can pass a message if you want, but super handy when you want to stub out. I think Scala has a function, I forget what they call it, but they have a similar thing saying, compile, I haven't done this yet, but let me off the hook. So those are sealed classes. I haven't used them a whole lot because they're still slightly strange. But if you like enums, but you don't like being able to not create multiple ones of them, there you go. So I'm going to keep going until someone says time. I think I have 10 minutes.
Can I ask you a question?
Of course.
You say that type on Kotlin, right?
Uh-huh.
Does Kotlin have void inside?
No, instead of void, it has unit. And unlike in Java, like all Java methods have to have a return type, so you'd say public void static main. In Kotlin, you could just say function main and take an array of string. Because it returns unit, that's an implicit return, or implicit type on that function, so you don't have to explicitly declare unit. You could say function main blah 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 colon unit, and the compiler would be fine, but it's redundant in the Kotlin syntax. Okay. Any questions before we hit coroutines? All right. Who has done asynchronous code? Who likes it? Yeah, there's a bunch of finger pointing in the back. The problem with asynchronous code, it's a lot of threads and checks and joins and what's going on. Some people love it, apparently, but it can get complicated. So Kotlin introduced coroutines. It gets a little bit of language, a little bit of compiler help, but they're basically, I don't want to call them lightweight threads because it's not exactly true, but you can think of them as lightweight threads. So you can spawn off a bunch of work off into a block of code, it'll go do its thing, you'll either come back to it or not. But the Kotlin compiler handles all the complexity of checking return types and suspending functions and this and that. So we'll look at a real quick example. So in this case, we're going to create I want to run 100,000 jobs, and that job, all that job is going to do, if we look at the function work, it's going to sleep for 1 second, and then it's going to increment an atomic integer. Okay? Not terribly fancy, but illustrative. So this is what this looks like. So we're going to create a list of jobs. See here, this is we're going to create a list of size 100,000, and this is the init block that it was so desperately trying to get me to provide moments ago. So launch is a keyword in the coroutine library that says go launch a job using, in this case, the default coroutine context. And the job that I'm giving it is the lambda that I'm passing in. In this case, it's just a single call to work num. So it's going to go launch 100,000 jobs, and then down here what I'm doing is I'm collecting all those launch returns a job reference, and I'm collecting them all in a list, which is what all this bit up here says. And now I'm iterating across that list saying join. If you've ever done thread.join and you join back in the whatever, it's the exact same concept. It's going to block until that particular job is done, and it's going to iterate across the list and make sure all the jobs are done. And when it's done, it's going to print out the final value. So any guesses as to how long this is going to take to run? It's 100,000 jobs. Compile. I think, there. It took longer to compile than it took to run, right? It's 100,000 concurrent jobs on the JVM. Now you may be thinking, you're pulling a fast one on us. Let's do the same thing with threads, okay? We're going to create an executor pool. We're going to start it. There's our integer thread. This repeat is basically like it's a function that's at Kotlin, one of the niceties about Kotlin. So we're going to repeat this block 100,000 times. We're going to go slightly more complicated, as you'll see why. Every 10,000 items we're going to print out, we're doing something. And then it's going to offer it to the queue, throw up a runnable. It's going to sleep and increment just like the other one did, right? And then we're going to wait until they're all done, but no more than 30 seconds because we don't have all night. And then we're going to print it. So, any guesses as to how long this will run? No brave souls. I don't know if I'll run it the whole way. I ran it earlier today just to refresh my memory how long it took. It took about 2.5 minutes to run 100,000 threads, and it took about 2 or 3 seconds to run 100,000 coroutines. So there's some real value in there if you're doing a lot of concurrent work or asynchronous work that Kotlin does the work for. As you can see now, we're just queuing up jobs. I mean, some of them are running because it's whatever, but right now we've only queued up 30,000 jobs, and it's still running, right? But we're not going to go the whole way because that's a little ridiculous. So, yeah. So it's clearly faster with coroutines, and it's simpler. I don't have a terribly complex example to show you necessarily, but I'll show you one thing to note. I didn't really go over it much, but you see this suspend keyword on the function. What this tells, the compiler will actually, when you use the coroutines library, it actually builds like a state machine inside to manage the state of your coroutine. Because what happens is, I think it changed, but when I first started playing with this, it was the fork join pool inside the JVM that came along with some of the Java 8 streams, parallel, whatever. So the default, will just for argument, will say is a fork join pool. So there's a number of threads that are already running. So what happens is, it'll collect all these coroutines, and it'll execute one of these coroutines for a little bit. It'll do some work until it hits a suspend point. In this case, it's a function call to work, which is annotated with the suspend keyword. When it hits that point, the coroutine engine will say, okay, we're going to pause this particular job. We're going to go work over here. So that instead of having to thread context switch between threads to run multiple jobs, the same thread just keeps running. So there's no context switching. It's just changing which method it's calling on which instance to keep it super simple. And then because it has a state machine inside the context to track this is this coroutine, it's in this state, and this one over here is in this state. and then the coroutine engine then can switch back and forth between these coroutines and execute them. So every time it hits a suspend point, it can go check and say, anybody else needs some work done, and it can switch around and not have to switch actual threads. Delay, you'll notice, is rather than thread.sleep. If you say thread.sleep inside of a coroutine, it'll actually sleep the thread that the coroutines are running on, which is a terrible thing because there's only so many threads. No other coroutine will run on that particular thread because you've just slept it, right? So delay is a suspendable function that does stuff to make it sleep, in this case, for a second. But it is itself, as you can see, a suspendable function. So if you're in a coroutine and you want to sleep for however, don't sleep, delay. So, but that's how the concurrency between coroutines can be maximized. If you properly segregate your code into suspend functions, you can break up your work in ways that can help the coroutine engine switch back and forth between work items. So, coroutines. What else have we got? All right, we're getting some esoteric stuff in some sense. Who's heard of Kotlin's multi-platform support? A couple of you. How many of you write Android apps? How many of you write iOS apps? Handful. How many of you write server backends? The rest of you, right. Well, probably if you write an Android app, there's something on the back end you're talking to, right? So chances are if you're writing a mobile app, there's a back end as well that you're talking to. Now the downside to some of that is with shared code, with Android it's a little easier because it's all sort of Java and you can kind of work, but with iOS it gets a little trickier because that's either Objective-C or Swift. So sharing your business models gets tricky. You have to make sure they all stay in sync. If you add a field on Android, make sure that Swift gets it so everything stays in sync. It's a management pain, right? So Kotlin has this thing called multi-platform projects. And it is, there's a lot going on here. You can actually create, there's multiple ways to do it. I created this particular module in IDEA. Everyone, who does not use IDEA? A handful, okay. I haven't tried it in Eclipse. It'll work in Eclipse because it's all Gradle based, but in this case I created this module inside IntelliJ just by saying create me a new module, and then one of the options is multi-platform. So what that means is, we're all familiar with the Gradle project layout, right? Source main Java, source main Kotlin in this case. You'll notice here, there's a whole bunch of stuff in here now, right? Can everyone read that in the back? So we have common main, we have common test, we have JS main and test, JVM main and test, macOS main and test. So what you're looking at here are all the platforms that this particular project supports. So there's the common, which is where all your common business objects would live. There's the JS side, because you can actually write Kotlin code and compile it to JavaScript, which is kind of cool. Any JavaScript people? A handful. I don't like the language, so I'd rather not write it. But now I can write Kotlin code and interact with JavaScript libraries from Kotlin, because it just compiles down to JavaScript. It's weird JavaScript, at least from what I've seen, but if you know JavaScript, maybe it's fine. But it's 100% pure Kotlin. It transpiles down to JavaScript. This is your standard, the JVM main. It's your standard JVM if you're writing your server backend. Now this is the interesting thing. This says Mac OS main. So using something we'll look at hopefully in a few minutes if we get there called Kotlin native, you can actually write Kotlin code, compile down to native machine code, whether it's Windows or Linux, ELF formats or Mac OS, whatever. In this case, I'm on a Mac, so it said Mac OS main. So you can actually write Kotlin code, interact with system libraries, and compile down, but you're still only writing in Kotlin. So what this means is you can come into common main, and you'll see we have an example. We have a class sample, and we have an object platform. Now you'll notice here it says expect. So because we're in the common module, what we're saying is this is our code, and we can expect on whatever our other platforms are, we can expect a type called sample, right? So in some cases, in the sample I've used earlier, like a date, the JVM has the date, either local time or Java useful date, so many dates to choose from on the JVM. JavaScript doesn't have one built in necessarily, so you can get to kind of choose whichever library you want to use for dates. but you're expected to provide one at that point. So there are some types you can have on the JVM that you can't have on JavaScript or whatever, so you have to kind of work around it. So you have expect classes, and normally when you have like a type and they're like subtypes, there's like a little arrow. You can go down to like, here's the implementation of this interface, and then maybe there's 8 of them, and you can see all of them in a list. In this case, we're going to expect a type. As you can see, we have 3 different kinds of samples. One is JavaScript, one is macOS, and one is JVM main. So each module has their own implementation of the sample class. And for JavaScript, you can see this is the actual class sample, and this is the actual object platform. So when everything gets compiled down for that particular platform, it will use these implementation details for that specific platform. But what that lets you do more broadly in your common module is you can refer to all these types as if they're just there, right? And then when it builds each particular platform that you're working on, it will use the local platform's actual implementation in order to compile down to executable code for that particular platform. So then, whether you're writing on Android or Swift or iOS or whatever, you can have one common set of code to rule them all and then compile down to your native stuff. At the, I don't know if they did it this year, but at the first Kotlin Conf last year, they had an Android app, they had an iOS app, and they had a web app, all written in Kotlin, top to bottom, front to back. There was JavaScript on the web page, they had an Android app and iOS app, 100% pure Kotlin, no native Swift, no native Java on Android. So this is, I think this is now final. It was experimental, whatever, but I think this is like public, usable, go forth and conquer sort of a thing. I'm quite excited about this. I haven't gotten to use it in anger yet, but I have a project that I abuse as I try out new things that this will be getting the treatment soon. It's really nice. So let's close that. What have we not got? Contracts. Okay, now this is a weird one. It's handy in certain targeted cases. Remember how I told you that Kotlin had those smart casts that you can check and see if it's null or not and then go do something inside that block? Sometimes it's useful, like, I wish I could do that. I need to write a function to like validate something and then use it without having to do additional checks. So what contracts let you do is they let you define an interaction hints for the compiler, basically saying, if this function returns in this particular way, then you can assume certain things about this code, right? Now, I'll show you one demo of it. The other one actually generates bad bytecode, and it blows up, because it is experimental, as we'll see. But this is new in 1.3. So, test. So in this case, you can barely see anything. All right, so we want to check and see. We're going to get a string, and it has a value. So we're going to check is valid, okay? So what is valid wants to check, it could be anything. First, make sure it's not null, and then maybe make sure it has a certain length, whatever. We're just going to validate the input, right? But what we want for sure coming out the side of that is we want it to be not null, right? We know that that's a hard requirement. But as you can see here, we're still having to do the null checks, right? Because S is a string up top. But if we look at the definition of is valid, this is what this looks like, right? Not exactly what we want, but we can define a contract here, and there's a whole lot going on here. So we have to enable it, so there's an @useExperimental annotation that tells the compiler we're going to play with some stuff. And in this case, we're going to use the contracts, right? Without that, this code actually won't compile because the compiler will, the branches that will compile that syntax get turned off. So we're going to do a extension function on the string type. Notice that we can actually define an extension function on a nullable type, which is nice. We can't call isValid on a string because isValid is only defined on a string. So in this case, we're going to define a contract, and then we're going to say returns true. So this says if this function returns true, it implies that this is valid, you can't see it, is not equal to null, right? So this is saying if this function returns true, we're implying that what got passed in, or in this case, the string reference that we're calling this on, we can assume that it's not null. So that tells the compiler everything's good. And then down inside it, we're going to say, if this is not null and it's not empty, right? So we don't care how long it is, as long as it has something in it. And then what this lets us do inside our tests is we can come and do this. We can say, if s.is is valid, let's go do something, right? So now we're inside the block. You can see this is now all in yellow because we don't need, it's a redundant null check, right? Because is valid, we told the compiler, if we get inside this block, then we know that s is not null. So in this way, we can influence the compiler to say, we can trust certain aspects of this, even though the syntax may not necessarily look the same. Now there's another thing here that if I enable it, it will explode. This is calls in place if you want like a late initialization. In this case, we're guaranteeing that the block passed in is only called once, so that val is basically assigned once, final. Once you give it a value, you can't reassign it, of course. But normally without, normally if it's a value, you need to give it a value right then, right? So, but in this case, we were going to call a function. We're going to do some stuff and assign a value. The compiler contract, without the contracts, this will fail to compile because x is val. And the compiler doesn't know what big block is. It doesn't know what to do with it, but it knows that x is val and can only be assigned once. If this particular feature worked, the contract would say this block is only run once, so it can guarantee that x has assigned once semantics around it, and then this would compile if that didn't generate bad bytecode and explode. But it does. All right, and then the last thing, coming up on 8:30. Now we already sort of talked about Kotlin native before, and I was going to run a demo and show you, but it's not building on this particular Mac, so I can't do it. But what I wanted to show you at least is what that source code looks like. So if we can find, that's not it, Kotlin native samples. There it is. Everyone remember Tetris? Yeah. Well, they rewrote Tetris in Kotlin, and I've run it and I've played it. It's fun, and it's still annoying, especially as it speeds up towards the end. So I was hoping to be able to show it to you, but there's Xcode set up and libraries, and I got weird errors. I'm not sure why. But I will at least show you what the code looks like. So. And there's an array of byte arrays, enums. This is all just standard kind of Kotlin-y sorts of things. And then if we come down, we're making moves, we're changing things around, blah, blah, blah. And then here's where we're drawing cells. And it's all just Kotlin code, right? Where did it go? But what we're... Why can't I find it? It's actually built on the SDL library. All right, we'll just look at the imports. Kotlin X, POSIX. Draw next piece. That's what I want. Visualizer. Anyways. I'm going to be here forever. Oh, it looks like they rewrote it. Maybe they rewrote it since I pulled this code. But this is all interfacing with SDL, which is, of course, kind of a native library installed on, in this case, Mac. But we're interacting with it. Maybe we'll go that route. This just highlights my point, like how great Kotlin native is. You can't even tell where the native code was anymore, right? It used to be a lot more obvious. There's C pointers and C doubles. There were special types introduced for Kotlin native. But if you just look at this code, like I was having a hard time finding what the native code looked like because it's all just like standard Kotlin code, which is kind of awesome. But Kotlin native lets you write Kotlin code and interact with native libraries in a reasonably seamless manner. So if there are, whether it's image processing libraries or big data or whatever, you can use your favorite standard native libraries and stay inside your Kotlin code for the most part. without having to break down. If anyone's ever done JNI or JNA, you know, not fun. There's a lot of ceremony, a lot of boilerplate in its work. But Kotlin Native lets you stay inside Kotlin, which is awesome, and not have to worry about some of this C stuff. So, all right, and that is the end of my table of contents. So we did it. I think we're slightly over, but whatever. I don't have anywhere to go. Did all that make sense? Were there any questions that I didn't get to? Yes?
I had one question way back at the beginning when you were talking about nullability and you have like the bar, the question mark, just raise your voice or whatever.
Yeah, string.
But is there some other name for that instead of just doing that all the time?
You could say it's a nullable string. Or well, I think formally it's called a nullable type.
But you don't say optional or use that.
If you want to use optional in Kotlin, you can, because you can use any Java library you want. It would be the same as using an optional inside Java, and you'd get no compiler support. You would work that in Kotlin the same way you would do in Java. It would feel like a step back for me to use optional in Kotlin, because I think the nullable types are much cleaner. And certainly if you're doing chained method calls, it gets simpler. Any other questions? Yes?
When you are showing delegation, is it possible to use by multiple times to emulate some sort of multiple?
I thought someone was going to ask that earlier, and they went off on a different tangent. I don't think so. The question was, is it possible to use multiple delegations on one particular item? I've never tried it, because it's never occurred to me. It's like, I should try this. I think in most cases, you're probably not going to want that.
Yeah, it sounds like a multiple inheritance of like multiple.
Yeah, kind of, and like, in what cases would you want to do multiple, like I want to delegate to this and to that. I mean, I suppose you can, if you had two separate lists, maybe it's performance timing, array list versus linked, and you want to delegate automatically to both. I don't think that's doable, but never tried it. Maybe if you did like by list 1, comma list 2, maybe. We can find out. List 2. No, that doesn't work. No. Now you can do delegations on fields as well. There's some like lazy delegation, and there's some delegations on nullability. It might work in those contexts, but I would be surprised as well. I think in most cases it doesn't entirely make sense, although I'm sure there's a case where you can make an argument for it. Any other questions? Okay. Post-mortem poll. Does Kotlin sound awesome to anyone who was unconvinced? All right. I'm getting some thumbs ups and some shrugs, so we'll take that as a victory. Okay. I love Kotlin. It's the first JVM language besides Java that it has enticed me away from writing Java code. I tried for years to like Scala. I've been reading Scala for the Impatient for 4 years now. And I can't get through it. But Kotlin is, it's so much fun to use. I've been using it for a while and ranting to my friends, and Tracy finally started using it in his project, and he's finally like, okay, I finally get why you and Joe have been talking nonstop about it. It is a really nice, really well thought out language. So.
Well, just as a testimonial, about 6 weeks ago, I had never touched Kotlin until about 6 weeks ago. So I said, I'm going to take a Spring Cloud task app. I'm going to spend a couple, 3 hours. I'm going to convert it to Kotlin. I did it in 25 minutes.
Yeah.
I mean, it was just smooth. I mean, I had to get past just a little bit of syntactic sugar, but I kind of haven't coded Groovy in the past. I said, okay, I know how this flows. I know how this is working. Wrote tests and converted one of their foundation task apps. Like I said, 25 minutes, and I went, wait a minute.
It's, yeah. It's pretty straightforward. And if you just want to play with it but not quite commit, if you're an IntelliJ user, there is a menu option. I don't know if it'll show me because I'm already in a Kotlin file, but there is, down here at the bottom, you can see it's grayed out. Maybe you can't see it. But there is an option here that says convert Java file to Kotlin. So maybe if you take a piece of Java code that you know really well, and you're like, what would this look like in Kotlin? You can convert it, and it takes half a second, maybe. That Java project I told you that I converted to Kotlin, I actually did that at the root. I just went to the root of it and said, all right, IntelliJ, convert this whole thing to Kotlin. And it did it. It didn't compile when it's done because it's not perfect. But if you're just in like a single source file and you're kind of curious, what will this look like? This is a great way to just kind of get a peek. So you start with something that you're familiar with, convert it to Kotlin and see, oh, that's what it looks like. And chances are it won't be terribly different than what you're used to. That feature does not exist. I mean, probably for obvious reasons. JetBrains wants everyone to go to Kotlin. But I've heard a story or two of people who've moved to Kotlin and said, this is, nope, not worth it, we're going to move back. But only like one or two, and they were.
They have valid reasons that you heard?
Well, to me, no. I mean, a lot of them are things, they sounded more along the lines of, well, we didn't really understand what you were doing, so we're going to blame Kotlin and move back. And that's probably an unfair characterization, but I know there were a few of those bullet points were like, but that's not really how Kotlin's supposed to work. Anytime you switch a language, Kotlin makes it easy because the syntax is pretty light in many ways, but there is a certain idiom in any language, whether you switch into Scala or Groovy or Ruby or whatever. If you try to write Java code in Scala, for example, you're going to hate Scala for more than just that it's Scala. So it's important to learn idiom, but Kotlin makes that gap pretty short for the most part.
Is it Kotlin kind of functional language shift or it's not?
I would call it multi-paradigm. I like to say that here's Java, straight up OOP, with a little bit of the streams adds some sort of functional stuff. And here's Scala, which tries to go like full-on functional with objects sort of a thing. Kotlin's somewhere in the middle. There's a lot of like really kind of arcane, obscure corners of syntax and features in Scala, which are powerful and people love them, that really get them. I can never get my brain to work that way. But with Kotlin, I get like 90% of the expressiveness that I would want out of Scala without weird things and confusing things like implicits that make your code hard to read or weird. Scala's fine. I don't want to just trash it all night. But it's complicated. Scala is my point, really. And Kotlin is designed to be a journeyman's language. They're not trying to break new ground. They're not trying to create new paradigms. They're taking everything that's been found to work over the last 40 or 50 years of programming language evolution and trying to combine it into something that works on the JVM and it works for everyday programmers who want to get the job done.
Overall, would you say that it's like safer than Java? Because I feel like a lot of people with the default kind of things that Java does, they end up writing bad code without realizing it.
I would, anytime you make a claim like that, someone's going to come up and say, well, what about? I think the nullability thing makes it fundamentally safer at a very basic level. You can still do stupid things because it's just code, right? But you have to go looking for them as opposed to like Java will sometimes let you just kind of wander into a null pointer exception because you just didn't know. But Kotlin kind of helps guide you into certain places. I would say in general it's probably a safer language in that sense. But I wouldn't necessarily use that as a selling point because it's a pretty debatable argument really. But yes, it's safer. Anything else?
Can you talk a little bit about the libraries and frameworks? Like for the Scala, there's a library and a bunch of things.
Oh, yeah. One of the hardest things I had about Scala is that when you move to Scala, you have to learn, you don't have to, but it's easier if you just learn a whole bunch of new libraries. Because the idioms are so baked into how the system works that Scala actually kind of needs a new set of libraries and able to operate correctly within the idiom that Scala defines, right? Kotlin was designed to be as interoperable with Java as possible, right? So you can use any library you want from Java. You just import it and use it, and it works fine. You can write. Hey, it finally went to sleep. You can write Kotlin libraries and use them in Java projects. I didn't cover it, but there's a number of annotations and things you can put in your Kotlin code so that when it compiles onto bytecode, like when you saw those companion objects in Java code, you'd have to have like extension functions dot companion. It's all in caps in the bytecode for whatever reason, and then whatever. You have to like fully qualify the whole thing out because it's technically like a nested class and they're static and everything. And it's weird to use it from the Java context. But there are annotations you can put on that field at JVM static, which just exposes all the members of that companion object as static members on the enclosing type. So you just say extension functions.foo. So there are steps that JetBrains has taken to make sure that not only can you use whatever Java library you want inside your Kotlin code, but you can actually write your library, your project, whatever, in Kotlin and still consume it from a Java library without tripping over the Kotlinness of the source code. If you've ever used a Scala library from Java, it's doable, but you'll notice there's weird sharp edges on the API that the Scala compiler would take care of for you, just as part of its process, but the Java compiler doesn't, so you have to do those things manually. And the Scala-ness of the API starts to leak into your Java code, which sometimes it's fine and sometimes it's weird. Class tags, for example. But Kotlin makes it pretty, I won't say it's seamless, there's a few rough edges, but they are very rare in my experience to be able to go back and forth. So in short, to sum up, there's no need to learn a whole new ecosystem of libraries because you can just take your Kafka driver or whatever and write your Kotlin code with it. Yeah. Yeah, and if you're a Spring Boot guy, you can go in and set Kotlin and it's all there. But yeah.
It seems like different should have those.
Spring. Yeah. No, Kotlin is awesome. It should be used everywhere. In fact, all my personal projects are now in Kotlin. I write Java at work, mostly, and it makes me sad, but it's a day job. Anything else?
So on the mobile platforms, is it a JavaScript engine running on them, or it's like a JVM, or it's a fully native application?
It's fully native. So if you're writing an Android app in Kotlin, it compiles down to JVM bytecode, and then I'm not an Android guy, so I'm probably going to screw it up, but you run it through Dex or Art or whatever it is that you deploy to the Android platform. It's just like it's Java bytecode. Just like you'd written it is JVM bytecode, but it's the exact same bytecode as if you'd written in Java. That compiles down to native. It uses, what is a compiler? It just left me. LLVM. It uses the LLVM bytecode, I believe, to compile down to native stuff. But there's no need for a JVM or anything on your iOS device. It's a normal, indistinguishable iOS app.
So JavaScript engine is embedded in this JVM.
Why, well, only if you want it to be. There's no JavaScript. Are you talking about like when you compile to JavaScript?
I mean, if you compare like React Native and Kotlin, so how do they work?
Oh, well, in this case, I think doesn't React Native like spins up like a JavaScript engine and runs. No, Kotlin Native is actual native executable code. Yeah. So there's no interpreter, there's nothing like that. It's native binary code on the platform. Yeah. And nicer to write because Kotlin's a nicer language than JavaScript. But okay. All right. I think it's now 8:40. If there's any more questions, I'm happy to chat afterwards. But thank you all for coming.